So we're going to look at different reaction types. This is question 4 on the AP chemistry test. You have to identify the different types in order to help yourself predict the products. You'll be given a word, the equation written out in words, and you'll have to write the formulas. So if you know the types really well, it makes it a lot easier to predict. So the first type, we have seen this before, synthesis. Synthesis means to combine. So just look for two things coming together. So in your word equation, you'll have two elements. So it's when two or more things combine, for example, two elements. A big clue that you have a synthesis reaction is that your two reactants are two elements. The only thing they can do is come together. There's no other reaction that can happen. In order to predict the correct products, make sure that you put the thing that forms a positive charge first, the thing that forms a negative charge second. Don't forget that your reactants could be diatomics, so Hofbrinkel, hydrogen is diatomic, oxygen, fluorine, bromine, iodine, nitrogen, chlorine. They all are diatomics. That's it. So let's try some. These are the easiest. Also, I guess another clue that you have a synthesis is that your elements, you know you have an element when it says metal, or ribbon, solid, strip, that just means you have a piece. So I've got lithium metal, I just have plain old lithium. And it's strongly heated in nitrogen gas, so I know I'm going to put it with N2. That's one of my Hofbrinkels. That's the N in Hofbrinkel, so it's diatomic. When I make my compound, the only thing I can do with these is put them together. Lithium forms a 1+, it'll go first because it's positive. Nitrogen forms a 3-, so I know I'm going to need 3 lithiums, so Li3N. And now I need to balance this, so I'm going to need 2 nitrogens, so I'll put a 2 there, and I have 6 lithiums. And that's it. So for the next guy, I have magnesium ribbon is burned in oxygen. So magnesium ribbon just means I have solid magnesium. It's burned in oxygen. Oxygen's also a Hofbrinkel. It's the O, the A. Okay, so O2. And when I make my reaction here, when I make my product, magnesium forms a 2+, so it'll go first. Oxygen forms a 2-, so it'll go second. And since magnesium's a 2+, oxygen's a 2-, their charges are already balanced. So I've got a good product. Now I balance the equation. Got 2 O's here, so I need to put a 2 here. Now I have 2 magnesiums, so I need 2 magnesiums. For pure solid phosphorus, the fact that it's solid, I know I just have phosphorus. Phosphorus actually comes in this form, P4. So I'll put that down. It's going to be burned in air. It's going to combust. It's going to react with the oxygen in air. And the product it's going to make is going to be P4O10. You wouldn't just guess that, you just have to know that this is the product that this guy makes. One clue, I guess, would be looking at if oxygen is going to be negative, it would form a 2-. Phosphorus has 5 electrons, it could be a 5+. So you know you're going to have a 5:2 ratio, and it just happens to exist in this form. You might get credit if it's P2O5, I'm not sure, but this is how it actually exists. And then we want to balance that. This is just one of those random things that you have to learn, that you have to memorize for AP chemistry. That phosphorus comes as P4, and P4O10 is the product that you make. So it'll show up again, at least. Alright, so I'm going to balance this guy. I can just see I need 5 oxygens, and now it's balanced. And then a strip of magnesium metal, that's going to be just Mg. It's strongly heated in pure nitrogen gas. That was nice of them to tell me what it's actually reacting with. N2, it's another diatomic. This guy forms a 2+, it'll go first. This forms a 3-, so I'll have to balance the 3- and the 2+. So Mg3 and 2. So now I've got 3 times the 2+ makes a 6+ on this side. 2 times the 3- gives me a 6- on that side. So the charges are balanced. And then I can just go ahead and balance the rest of this. I've got 2 nitrogens, I just need 3 magnesiums. Okay, and so those are synthesis reactions.